Hi, this is Mr. Ward, and I'm going to do my second installment of the rational functions tutorial. We're going to take from the last video, we started with the function of x equals 1 over x, and that made this nice little curve where we have the y-axis being the vertical, what's called the vertical asymptote, and the x-axis being a horizontal version of an in-behavior asymptote, because the function, as it gets bigger in a positive or negative direction, as x gets bigger in a positive or negative direction, the function tries really hard to be the x-axis, so it defines its behavior at its ends. On the other hand, here in the middle, it goes all wonky because you can't divide 1 by 0. Okay, I'm going to go ahead and turn the x and y axes back on so we can see where they are, because I'm going to mess with this function. I'm going to change the function. Instead of 1 over x, make it 1 over x minus 2. So what that's going to do for us is it's going to change one thing. It's going to change what the denominator, what x value cannot be used as an input in the denominator. Well, the x value that can't be used is any x value that would make x minus 2 equal 0. So the x value that can't be used is no longer 0. The x value that can't be used is what would make x minus 2 0, and that happens to be 2, because 2 minus 2 is 0, and then we're dividing by 2. So I'm going to have a vertical asymptote right there, and my function's going to try really hard to get close to it as it approaches 2 from either side, but it's just never going to get there. On the other hand, I'm still going to have an in-behavior asymptote that's just going to be the x-axis, because this function, whatever x is, 1 over something is never going to equal 0. So we're still going to have y equals 0. And I'm going to go ahead and turn off that x-axis, which is y equals 0, so you can see it. So the in-behavior will be defined by that. So in this time, we're going to go down here. I'll change my table of values. Now, instead of 1 over x, I have 1 over x minus 2. And it shifts everything. Now, take a look. 2, before it was 2 would give us negative point, would give us 0.5, and 0 gave us undefined. Now, when I change that to minus 2, now 2 gives us undefined, and 0 gives us something. So if I click on that, it gives us points. And I can zoom out a little bit, and you can, well, actually, looks like I lost some points. Let's take a look. Well, that's very interesting, because I'm no longer trying to get closer and closer to x equals 0, my inputs of 1/2 and 1/3 and so forth don't really help illuminate anything. So I'm going to get rid of those, and we'll try and figure out what would work. Well, since now we're trying to, our function tries to get as close as possible, keeps getting closer and closer to x equals 2, what we want to do is we want to pick numbers that are just beyond 2. So 2.5 and 2.3 and 2.2 and 2.1 and 2.05, for example. So get closer and closer to 2, it shoots up, because what that means is I'm doing 1 over 2.05 minus 2. So it becomes 1 over 0.05, or 1 over 1/20th, which then again becomes 20, just like the previous one where I said x over 1/20th gave me 20. All right, I can do the same thing on the other side. 1.5, so I'm half away. 1.7, 1.8, 1.9, 1.95, and so forth. And I get closer and closer. As I get closer and closer to x equals 2, the function shoots off on the left in the positive direction, and on the right in the positive direction towards infinity, and on the left it shoots off in the negative direction towards infinity. Now, in the last video, I neglected to do something when I turned the function on. When I turn the function on, you can see it heads down like that and heads up like this, and it looks like it's a vertical line. But what would be useful for us to do is to zoom in on some point down here that looks like it is, the function is on that vertical asymptote. As you zoom in and get really, really close, we see there's actually some gap between them. Okay, so I'm going to zoom out again. We can look even further. If I zoom in again, we will find, as we zoom in close enough, that there is some daylight between our function and our vertical asymptote at x equals 2. Now, eventually, I could probably find some point on Desmos where we've gone beyond what Desmos can calculate, and it won't be clear that there's a gap. But I assure you there will always be a small gap, a small wedge between the function and the asymptote. It'll always get smaller, but this function will never touch the vertical asymptote. Now, same thing in this case with the in behavior or horizontal asymptote, which happens to be horizontal in this case. If I go off in this direction for a ways, this function tries really, really hard to be the x-axis, but it never can get there. All right, later on, we'll take a look at the in behavior asymptote and how it behaves not at the end. Sometimes the function will cross an in behavior asymptote in the middle. Now, the key point there is that the in behavior asymptote is the asymptote that defines the ends of the function. So let's play around with this just a little bit. We'll change this to, let's change it to x plus 2, and now we have moved over in the other direction. We no longer have, oops, I made a mistake, that's x plus 22. X plus 2, we no longer have a vertical asymptote at x equals 2. Our vertical asymptote is actually now at x equals negative 2, because negative 2 plus 2 would make a denominator that's 0, and our function will not exist at x equals negative 2. Our in behavior asymptote remains the same because 1 over something will never be 0, but it can get close if the denominator gets ginormous in a positive or negative direction. All right, that's all for this video. I invite you to play around with moving this around. Oh, actually, there is one more thing. I do want to note that what I've done here is I've used transformations. I've used horizontal transformations. So I change this to just minus h. We add a slider, and instead of saying x equals negative 2, we just say x equals h. Whatever I do with that, my vertical asymptote will stay whatever h is. Right. I can also make vertical changes as well. I'll just do that just because I can, and I'll set a k value there. And as we, and I'm going to change this to k, and we will make that play as well. And it's going to go up and down. My in behavior asymptote stays with it. I'll turn that on, and you should play with this. And the video is just about out of room. And I'll stop.